Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter atomic structure. So in this session we are going to have small introduction about the atomic structure. All the materials around us are made up of very tiny particles called atoms. From the stars to your favorite ice cream. These all are made up of very tiny particles called atoms. Of course, they might be made up of different components. So those components, if you observe inside, there will be certain molecules. Those molecules are made up of, again, small tiny particles which are called as atoms. So everything in this universe, if it is said to be a matter, it is made up of atoms. Who might think that to make these all materials, there must be many different kinds of atoms, isn't it? We see around us so many kinds of materials which are made up of different kinds of matter. So we might have think that there should be different so many kinds of atoms to make these many different materials. But in fact, the number of different kinds of atoms is surprisingly very small. It is almost around 118 elements, isn't it? Till the date, we know around 118 elements only. So, only with these 118 elements only, these all crores of different kinds of materials are made. How it is being possible? So, these atoms or these elements, which are there 118, these are combining themselves and with the different elements in different ratios to form different molecules. So these different molecules resulting in different kinds of materials. So we're able to see different, so many kinds of materials around us. These all kinds of materials are made up of only these 118 elements. Out of these 118 elements, around 90 elements are found in the nature. Naturally occurring elements are 90 around, and the remaining elements are created or prepared from the laboratory. So they are called synthetic elements or artificial elements. Only around 90 elements are naturally occurring and naturally available in the nature. Remaining elements are prepared in the laboratory from already existing elements by combining two or more or by destroying some of those. So in this way, some are naturally existing and the remaining are prepared in the laboratory, which are called synthetic elements or artificial elements. So anyhow, totally there are available 118 elements only so far. These 118 elements are only responsible for the existence of these many crores of materials which we see around us. Okay, how can atoms join together to make molecules? How do these molecules atoms are combining, or how these are being joined together to form these molecules? What makes some atoms more ready to do this? What is the reason for making these atoms to be very ready to combine with other atoms? Why do hydrogen atoms pair up very easily, but helium atoms remain single? What is the reason behind this? To find answers for this kind of questions, we need to first consider the structure of atom. What is the generalized structure of atom? If we understand, then we can get answers for these all. What are those? Why atoms are joining together to form molecules or different compounds? Why some atoms are very ready to pair up easily, but why some other atoms are being remain single? So for this all, we get answers when we get an idea about the structure of atom. That is how these atoms are structured. What are the arrangements of inside particles of these atoms? That we say simply structure of atom or atomic structure. So if we have a generalized idea about the structure of atom, then we can get answers for these all questions. Okay, let us see that now. A major challenge before the scientists at the end of 19th century was to reveal the structure of the atom as well as to explain the important properties of these atoms. It was a main task at the time, in the 19th century, at the starting, scientists they have done so many experiments, so many investigations and researches on these matter and the particles present inside the matter to give idea about the structure of the atom and to understand the important properties of these atoms. So the education of structure of atom is based on a series of experiments. Yes. So to give this, to reveal the structure of the atom, to explain the important properties of these atoms, they have done so many experiments. So these all structure and properties of the atoms study based upon these series of experiments. So one of the first indications that atoms are not indivisible. So in the earlier days of science developments, scientists they have thought that atoms are the smallest particles of every matter. So matter might be made up of compounds and particles. These particles might be made up of molecules. So in those molecules there are atoms. So they thought that atoms are the smallest particles of every matter, and these atoms cannot be broken down into smaller particles. These are the smallest they have thought. These are indivisible they thought. But later on, the experiments proved that atoms are no more indivisible. They're also divisible, and they contain some smaller particles still. So many scientists explained and proved the presence of charged particles inside the atom. So by the discovery of these particles present inside the atom, the concept of indivisibility of atom was failed. Okay. Next, the existence of atom. The electrical nature of matter was known in 600 BC. So here we are going to see the serial developments, the how they have done the experiments, what they found first. So in which way the structure of atom is being designed or supposed. So first of them, at the earlier stage, they have found in around 600 BC itself, the electrical nature of matter was found. They came to know that yes, matter is existing with some electrical nature in 600 BC. Next, William Crookes was the first to do the discharge tube experiment, which led to the conclusion that atoms are containing some charged particles inside them. So this was first proved by the scientist William Crookes. He did an experiment called discharge tube experiment. What is this? In that he took a cylindrical glass tube, hard glass tube he took there, and which is closed at both ends. Now he introduced some gas into the discharge tube with very few molecules of gas. He introduced it into that, and he decreased the pressure of the gas inside by using some vacuum creator as a gas sucker. Now he introduced two electrodes into this glass tube, which he called as discharge tube. On passing high voltage current by using these electrodes into the discharge tube, he observed some charged particles are being emitted in by that gas. He observed some glow or some scintillations on the screens kept at the edges of this discharge tube at the back of these electrodes. So from those scintillations observed on the display chart, he concluded that some charged particles are being emitted by the atoms when high voltage electricity applied at very low pressures. So from these experiments, he concluded that atoms are containing some charged particles inside them. Okay, this was done first by William Crookes. So the existence of charged particles was identified by the experiment called discharge tube experiment. The first important and experimental evidence of electrical nature of matter was established by Michael Faraday in 1833. So the electrical nature of matter was established by the scientist for the first time by Michael Faraday in around 1833. He proved the electrical nature of matter. He showed that the flow of electricity through matter is due to the flow of charged particles through the matter. So he observed that the flow of electricity through the matter. He identified that this flow of electricity through the matter is because of the flow of charged particles inside the matter. So this also proves the existence of charged particles inside the atom. So this was done by Michael Faraday. Next, the term electron was suggested by G.J. Stoney. The term electron, this is the term given for the charged particle present inside the atom. So the term electron was the first time suggested by the scientist G.J. Stoney for unit charge on a monovalent negative ion. So monovalent means a single charge. So the ion with a single charge, with a negative single charge ion is given because of that negative charge is given the name as electron by the scientist G.J. Stoney. So one unit negative charge is called as electron. Later on, the existence of electron was proved by J. Thomson by his experiment, the same like William Crookes experiment. He also done the same discharge tube experiment, and from that he proved the existence of electrons inside the atom. He called these particles as cathode rays. The name electron was given for these cathode rays as by G.J. Stoney. Okay. Next, the idea of tiniest unit of matter was proposed by Maharshi Karnad in Vedic period in our country. So in the Vedic period itself, from our country, our philosophers, one of the philosophers was Maharshi Karnad, proposed that every padartha is made up of anus. These anus are composite of still smaller particles called paramanus. So here, a padartha represents matter and anu represents molecules. And these anus are composite of paramanus. These paramanus represents atoms. So every matter is made up of molecules. These molecules are composite of two or more still smaller particles called atoms. So from this also, in the Vedic time itself, in our country, they have given the concept of atom by the scientist or philosopher Maharshi Kannad. He told that every matter is made up of molecules. These molecules are composed of still smaller particles called atoms. Okay, the same was given later by Democritus in the 400 BC around. He told in 400 BC, a Greek philosopher Democritus proposed that matter is made up of extremely small particles called atoms. The word atom means indivisible. So the particles, the tiniest particles of every matter which are indivisible are called as atoms. This atoms term was proposed by Democritus. Based upon these concepts which were given by Democritus, one more theory of atom was given for the first time by John Dalton. So the first atomic theory was proposed by John Dalton. He stated that all matter consists of indivisible particles called atoms. He told that all matter is made up of very smallest particles and which are indivisible called atoms. Atoms, next point in the Dalton's atomic theory is atoms of the same element are similar in all respects like shape, mass and these all. So atoms of the same element are same or similar in all respects. For example, if you take carbon element, if you take the atoms of carbon from certain place, and if you collect the same element carbon from other place, somewhere else, if you observe the atoms of these two, they will be similar in all respects. They will be having same mass, they will be having same shape, same structure. These all will be similar for all the atoms of an element. It is one of the proposals given by John Dalton. At the same time, he told that atoms of different elements different in all respects. Means if we collect the atoms of two different elements, if we observe the properties of these two atoms, they will be having entirely different properties. No common properties will be there for the atoms of different elements. For example, as we told now, if we collect one carbon atom, and if you take one of the other elements atom like oxygen, if we take these two atoms of carbon and oxygen, they do not have any similar properties. So from this we can say atoms of same element are similar in all respects, but they differ from the atoms of other elements. Okay. Next proposal given by John Dalton is atoms cannot be created or destroyed. Yes, atoms are the smallest particles of every matter and which cannot be divisible, and they cannot be created or they cannot be destroyed. Simply to say, atoms neither be created nor be destroyed. Next proposal or point given in the Dalton's theory is atoms of different elements may combine with each other in a fixed simple whole number ratios to form compound atoms. Yes, atoms of different elements or atoms of different elements, they may combine chemically in fixed simple whole number ratios to form compound atoms. For example, if we take two elements, hydrogen and oxygen, these two will combine the ratio 2:1 to form a molecule which is called compound atoms is formed. So this compound atoms is called molecule. So molecules are formed by the combination of different elements in simple fixed whole number ratios. This is one point. One more point in the Dalton's theory is atoms of same element can combine in more than one ratio to form two or more compounds. Yes, it is also true. Just now we have seen here hydrogen and oxygen, they combine in the ratio 2:1. The same elements, they may combine in the other ratio. Here in this ratio is 2:1. If these two combine in some other ratio like 2:2 or 1:2 ratio, then they form one more compound which is called as hydrogen peroxide. So what is the conclusion here? Atoms of same elements, they may combine in more than one ratio to form two or more different compounds. Okay. Next, the atom is the smallest unit of matter that can take part in a chemical reaction. Yes, atoms are the smallest particles of every matter which are participating and taking place in the chemical reactions. But today, the indivisibility of an atom was proved wrong, and Dalton theory is almost discarded after the discovery of fundamental particles. Yes, as nowadays they have discovered the particles present inside the atom. So this discarded the Dalton's atomic theory, because Dalton's atomic theory is completely based upon the concept that atoms are the smallest particles, but they discovered the particles present inside the atom nowadays. So Dalton's theory is discarded. Almost all the points were kept failed. Only one or two points are being correct even till now. One of them is this one. If you say atoms are the smallest particles of every matter, this is true even now. Atoms are the smallest particles which are taking place in the participating in the chemical reactions, and atoms combine in different ratios to form molecules. Of course, this also will be true. But here, not only the simple whole number ratios, in complex compounds also being formed. So, remaining all concepts are being failed which were proposed by John Dalton, except one or two like this. Okay, this was failed. This is Dalton's theory is discarded mostly after the discovery of particles present inside the atom. Those particles which are present inside the atom are called as fundamental particles or subatomic particles. Now let us say about these subatomic particles here. So out of those, the important and first one is electron. These were earlier called as cathode rays. Okay, cathode rays were discovered by J. Thomson by the experiment called discharge tube experiment. Okay, in that he found that atoms are producing some negatively charged particles when high voltage is applied. He called those negatively charged particles as cathode rays. So cathode rays were discovered by J. Thomson. So some properties of cathode rays are mentioned here. These cathode rays travel in straight lines. These cathode rays consist of material particles, not just the charge. They can consist of material particles. Cathode rays are affected by both electric and magnetic fields. As these cathode rays are consisting negatively charged particles, so these are being affected by both electric field and magnetic field. When they are traveling in a path, if electric field or magnetic field is introduced in their path, these are being deviated from their original path. The charge to mass ratio, which is also called specific charge of an electron, E by M ratio also it is called simply. Charge to mass ratio or E by M ratio is called specific charge. So the specific charge of an electron is always constant from wherever it is produced. It is equal to 1.76 into 10 to the power of 11 coulombs per gram, or 10 to the power of 8 coulombs per, 10 to the power of 11 coulombs per kg, or 10 to the power of 8 coulombs per gram. It is a specific charge of electron. From whichever the element if these electrons are produced, its a specific charge is being constant, irrelevant of the gas taken. Okay. Next, the charge of electron. The charge of electron is the smallest unit of charge, which is equal to minus 1.602 into 10 to the power of minus 19 coulombs, which is also equal to 4.8 into 10 to the power of minus 10 ESU, which is a smallest unit of charge. It is called. It is it's in the expanded form. It is called electrostatic unit. ES it is simply called. Okay, this is the charge of electron. It is given negative charge as because electrons are having negative charge. The quantity is 1.602 into 10 to the power of minus 19 coulombs. And the mass of electron. Actually, the mass of electron is very small when compared to the mass of one hydrogen. Mass of electron is numerically equal to 9.11 into 10 to the power of minus 31 kgs, or 9.11 into 10 to the power of minus 28 grams. So the mass of electron is nearly equal to 1837th part of mass of one hydrogen atom, or 1 by 1837 the mass of the one atom of hydrogen. So around 180 1837 electrons together equal to the mass of one hydrogen atom. So in this way, if we compare the mass of electron, we can say as very negligible, very minute. Next, about protons or anode rays. Actually, after the discovery of electrons, they have discovered anode rays or canal rays. These are nothing but positive rays. From the same experiment, discharge tube experiment, one more scientist, Goldstein, discovered these anode rays or canal rays. These anode rays also, just like the cathode rays, they travel in straight lines. Almost all the properties are being similar to the cathode rays. But these anode rays or canal rays are positively charged particles. They consist of positively charged particles, whereas cathode rays are consisting of negatively charged particles. Anode rays cause mechanical motion, and these are positively charged particles. Anode rays are deflected both in electric field and magnetic field, just like the cathode rays deflected. But here, these will be deflected in the opposite direction to them. In the electric field, these anode rays deflect towards a negative plate or negative electrode because these anode rays are positively charged. So they deflect towards negative electrode. And in the magnetic field, these anode rays deflect towards south pole. Okay, next one. The E by M ratio, which is called specific charge of these anode rays, it is not being constant. This specific charge is being changed, and it depends upon the nature of the gas taken in the discharge tube. It changes from gas to gas. That means the positively charged particles are varying from gas to gas. So the gas taken, so the E by M ratio or a specific charge of these anode rays depends upon the gas taken in the discharge tube. Next, the charge of proton is 1.602 into 10 to the power of minus 19 coulombs. If you observe, the quantity of charge of protons and electrons is being same, 1.602 into 10 to the power of minus 19 coulombs. But electrons are having negative charge, whereas the protons are having positive charge. So here in electrostatic units also, we can say 4.8 into 10 to the power of minus 10 electrostatic units. So here the point is, all the cathode rays can be considered as electrons, but all the anode rays or canal rays will not come under protons. Anode rays or canal rays are nothing but positively charged ions produced from a gas when high voltage current is passed into discharge tube. Out of these anode rays, the smallest particles or the smallest positive ions produced are called as protons. So the smallest particles of anode rays or canal rays are called as protons. For example, when the hydrogen gas is taken in the discharge tube, when high voltage current is passed, then this hydrogen gas will produce electrons, cathode rays, and H plus ion positive rays or anode rays. These H plus ions are considered as the smallest particles of anode rays out of all the gases we take. So these H plus ions are called now protons. So the charge of each H plus ion or proton is considered as 1.602 into 10 to the power of minus 19 coulombs. So cathode rays are same. They won't be dependent on the nature of the gas taken in the discharge tube. But the anode rays are different for different gases taken. Out of these all kinds of anode rays, the smallest anode ray particles are called as protons. Those are nothing but H plus ions. And their mass is equal to 1.672 into 10 to the power of minus 24 grams. It is the mass of one proton. In AMUs, it can be told as 1.007 AMU. Here AMU represents atomic mass unit, the smallest unit of mass you can say, AMU. So nearly it is equal to 1 AMU. The mass of proton is nearly equal to 1 AMU. AMU is nothing but atomic mass unit. In grams, if you take it as 1.672 into 10 to the power of minus 24 grams. Okay, next about neutrons. These neutrons were discovered by James Chadwick. The mass of neutron is slightly more than that of a proton. That is 1.676 into 10 to the power of minus 24 grams, whereas the mass of proton is equal to 1.672 into 10 to the power of minus 24 grams. So slightly it is heavier. It is a 672 here, whereas it is 676. Remaining it is the same. So slightly heavier mass. Neutrons are slightly heavier, but in general, the mass of proton and neutron is considered same in the calculation generally. Okay. Electrically, a neutron is neutral. That means it has no charge. Neutrons are chargeless particles, electrically neutral particles, whereas electrons are having negative charge, protons are having positive charge, but here neutrons are electrically neutral particles. They do not possess any charge. In a particular element, the number of neutrons in the nucleus of its atoms may vary. Yes, some atoms may have certain number of neutrons, but some other atoms of the same element, sometimes they may have less or more number of neutrons in those atoms. So neutrons number may not be same in all the atoms of an element. They may vary. So because of this, different isotopes are existing for an atom. So about this, we are going to see about the isotopes and these in the remaining next further classes. Now, the number of protons will be fixed in all the atoms of an element, and number of electrons some will be equal in all the atoms in the neutral condition. But number of neutrons may be varied from one atom to another atom in different elements. Further research has proved that within the atom, there are over 100 different kinds of subatomic particles. Most important being positron, meson, neutron. Yes, actually we have seen till now about electrons, protons, neutrons which are present inside the atom. But not only these three particles present inside the atom. Along with this, totally 100 different kinds of particles are present inside the atom. These all are called subatomic particles only. But out of this, these three particles are being much stabler. That is why these are specially called as fundamental particles. Electrons, protons, neutrons are called as fundamental particles. And along with this, there are different kinds of particles still. Some of them are given mentioned here. See, positron, meson, neutrino. These are also present inside the atoms. But out of these all kinds of particles, only these three electrons, protons, neutrons are being much stabler. That is why these particles are called as fundamental particles of every atom. Okay, this is about different fundamental particles or subatomic particles present inside the atom. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos.